So the next thing we're going to do is solve a system of equations that has fractions. So there's two ways of going about this. Way number one, don't fear fractions, right? Maybe take this equation and isolate x, right? Make x equal 8 plus 1 half y, then plug that in for x. But can you see how complicated that's going to get? You're going to end up with just like a world of fractions. So instead, what I recommend you do, if you have an equation that starts out with fractions, is get rid of the fractions. We learned how in chapter 1 to get rid of linear equations that had fractions in them. We multiplied by the lowest common denominator. Well, we can do that here. So for this one, what would be my lowest common denominator? So for the first set of terms, I've got x over 1, I've got 8 over 1, and I have a 2. So my lowest common denominator is going to be 2. So I'm going to take this top equation and I'm going to multiply it by 2. That means I'm going to take every term and I'm going to multiply it by 2. That's going to end up with, and you know what, maybe I should show more steps. Sometimes it's just nicer, right? There's no harm in showing more steps. Okay, so we have this over 1, we have this over 1. My lowest common denominator is 2. So I'm going to take this entire equation and I'm going to multiply it by 2. So I'm going to take 2 times the x minus 2 times 1 half y is equal to 2 times 8. And I do this purely for the fact that I have this one fraction where I want to go 2 divided by 2 is 1. That would leave me with an equation that's 2x minus y is equal to 16. Then I'm going to take this equation and I'm going to say, what's its lowest common denominator? Well, I have a 3, I have a 2, and I have a 1. So my lowest common denominator is going to be 6. I'm going to take every term and I'm going to multiply it by 6. I'll end up with 6 times 2/3 x plus 6 times 3 halves y is equal to 6 times negative 2. The whole reason I do this is because I multiplied by a number that all the denominators divide into. So this is 6 divided by 3 is 2. This is 6 divided by 2 is 3, and then this one doesn't have a denominator. So then my new equation would be 2 times 2x, which is 4x, plus 3 times 3y, which is 9y, is equal to negative 12. So this is my new system of equations. Really, the question could start here. As long as I haven't made any mistakes, these equations are equivalent. So I've got 2x minus y equals 16, and I have 4x plus 9y is equal to negative 12. Now, it's up to you. Do you want to solve this by elimination? Maybe I want to make the coefficient on x 4. So I'm going to multiply this equation by something like negative 2, because then I'd have negative 4x and positive 4x. Maybe I want to take this top equation and I want to multiply by 9. Because if I multiply by 9, I would end up with a negative 9y and a positive 9y. If you pick the ones that already have opposite coefficients, you just have to multiply by something, not a negative. Maybe I want to take this equation and I want to solve by substitution. I want to take this equation and solve for y. Get y equals and then plug that into the second equation. So what I would encourage you to do actually is pause the video right now, pick a method and solve it. It would be good practice of looking at a question and being like, what do I want to do? Do I want to do elimination? Which variable do I want to get rid of? Do I want to do substitution? Now, if you're doing substitution, I would only solve for that y, right? Always pick the variable that has a coefficient of 1. So it's really up to you. If you've paused the video and give it a go, then you're just going to want to check you get the same answer as me. If you don't know what to do, just keep watching. Now, usually in a class, I'd be like, okay, majority rules, what do you want to do? I'm just going to make a guess of what I think you're going to do. My guess, if I had to pick for you, was I'm going to guess that you're going to multiply this top equation by negative 2. And I could be wrong, but I feel like it's a smaller number. People are scared of multiplying by 9. And even though this is negative, that's okay. So if I multiply this entire side by negative 2, I get negative 4x plus 2y is equal to negative 32. This bottom equation I'm not multiplying by anything, so I'm just going to rewrite it as 4x plus 9y is equal to negative 12. Now I'm going to add my two equations. I get negative 4x plus 4x is 0x, so it's gone. I have 2y plus 9y is 11y. And I have negative 32 plus negative 12 is negative 44. Now to get 11 by itself, I'm going to divide both sides by 11, and I end up with y equals -4. Now that you have y equals -4, I would normally recommend taking this y equals -4 and plugging it into the original equation to solve for x, but I wouldn't. Personally, I'm like, man, I'm pretty confident in my skills that I don't think I've messed up getting to here. Like, that is the only harm. If you plug the y into here, actually, it's not even that bad. Let's plug it into one of these. Let's plug it into the top one. If I plug it into the top one, I've got x minus 1/2 y is equal to 8. If I plug in -4, it's nice because it actually divides by 2, right? So then I end up with x minus 1/2 times -4 is +2, and then I'm just going to minus 2. And I end up with x is equal to 6. So they don't always end up like that, nice like that. So if it ever ends up that you're like, I don't want to plug it into there, you are able to plug it into one of these two equations, right? I could plug it in here or here. Like if you are confident that you have rearranged your equation, or not rearranged, but multiplied by the correct thing to get rid of the denominator and you haven't made any integer mistakes, plug it in there. Right? But if you're nervous, I would plug it into the original just to make sure it works. And then I would check this by plugging by plugging, I'm in the wrong color, my answer. So always state your solution. So my x value is 6 and my y value is -4. This is where the two graphs would intersect. If you want to make sure that this is true, you're going to plug in 6 for x and -4 for y in both equations. 2/3 times 6 plus 3/2 times -4. Does that equal -2? Right? So this is my check. So you could plug this into your calculator, right? 6 minus 1 divided by 2 times -4, or you can do it in your head. This is -1/2 times -4, which we already said was +2. We already knew this one was going to work. Technically, when you check, if you have substituted in to get one of the x values, you can just check into the other equation. So for this one, I've got 2/3 of 6. So I'm going to do 6 divided by 3 is 2. 2 times 2 is 4. For this one, I'm going to do -4 divided by 2 is -2. 3 times -2 is -6. And I get -2. So it made left side equal to right side in both of the original equations. So then I know for sure that my answer, so my loose solution set, would be the point -6, -4. Awesome. Good luck with those.